Hello students, in today's video we are going to discuss about some more differential equations which are not in Leibniz form in first phase, but after some modifications we can reduce them to Leibniz form. And for Leibniz form we are well aware that how we can find out their solution by making use of integrating factor. अभी क्या डिस्कस करना है अभी कुछ इक्वेशंस होंगी हमारे पास डिफरेंशियल इक्वेशंस जो लिबनिज फॉर्म में नहीं होंगी, बट हम किसी न किसी मेथड से मॉडिफाई करके सब्स्टिट्यूशन करके उनको लिबनिज फॉर्म में कन्वर्ट कर सकते हैं। और लिबनिज फॉर्म कन्वर्ट करने के बाद तो हमें पता ही है कि उनका सोल्यूशन हमने कैसे कैलकुलेट करना है। लेट्स हैव अ लुक एट वन एग्जांपल। क्वेश्चन नंबर 1, कंसीडर द डिफरेंशियल इक्वेशन tan y dy by dx plus tan of x is equals to cos y cos square x. Now this is the differential equation for which we need to find out its solution. इसका solution अब हमने calculate करना है. If you look at this equation, no doubt this equation is of first order and first degree, but this is not the Leibniz form. Why? Because this is not linear ना. देखो, neither it is linear in y में तो linear है ही नहीं. अगर आप देखो यहाँ पे tan y present है, linear में हमारे पास ये option नहीं होती है. linear का मतलब है कि जो dependent variable है that should be of only degree 1, वो सिर्फ y की फॉर्म में होना चाहिए. Secondly, जो सेकेंड टाइप थी there was other type which is linear in x. This is not also possible that we can convert it into the form of dx upon dy. Why so? You can see tan x and cos square x are also present there. तो दोनों में से बेसिक फॉर्म तो वो भी नहीं बनेगी, neither it's linear in x neither it's linear in y. Now what we are going to do, we will do some necessary modifications and convert it into the form of Leibniz linear differential equation. If you remember, the general form was dy by dx plus p of p of x y is equals to q of x. And if you observe, the right hand side in Leibniz form is always free from y. Na? There is only a qx which is a function of x only. So making use of that thing, what I will do, I will try to remove this cos y by dividing this equation both sides by cos of y. Now let's divide. Let's say this is equation number 1 with cos of y. When I will divide this equation, what I will get here? Tan y upon cos y dy by dx plus 1 by cos y tan x is equals to cos square x. Just simplifying this equation, I am writing 1 by cos as secant y dy by dx plus secant y tan x is equals to cos square x. So I have achieved my first step, which was to make right hand side free from y, and we are done. Now the second step is to do the substitution. Whenever you are going to solve similar problems, whatever you get here in the form of y, जो भी आपको बच्चा यहाँ पे y की एक्सप्रेशन मिलेगा y में, जैसे यहाँ पे क्या मिल रहा है secant y, जैसा भी फंक्शन आपको मिलेगा आपने उसको क्या पुट कर देना है, z या t कोई भी एक वेरिएबल नया पुट कर देना, जो भी मिलेगा यहाँ पे इन द सेकेंड टर्म में जो भी y का एक्सप्रेशन मिलेगा आपको उसकी आपने सब्स्टिट्यूशन कर देनी है. सो आई विल यूज इन आवर सब्स्टिट्यूशन हियर, पुट secant y is equals to let's say z, उसको हमने z पुट कर दिया. Do the differentiation, derivative of secant is secant into tan dy is equals to dz. And always remember, when you are going to do the substitution na, then after doing the differentiation always you will get the same expression here, always. हर बार ना आपको यहाँ पे ये सेम चीज़ मिलेगी. See, they can vary by a constant, like here you can have a constant multiplied by 2 like that, but the mathematical expression is going to be same, secant y into tan y. Now substituting the values in equation number 2, what we get from equation number 2, dz upon dx plus tan x secant y is z is equals to cos square x. Now see, isn't it a Leibniz form, but it's linear in z now, not in y, because we have substituted y as z. y को हमने z में convert कर दिया है. अब ये कौन सी form बन गई है? Now this is Leibniz form but in z, like this. See, dz by dx plus p of x z is equals to q, है ना? So this is Leibniz form. And what is the value of p here? P is equals to tan x and q is equals to cos square x. Now let's move to the other part. Now next step क्या होता है हमारा, to calculate the integrating factor, which is given by e raised to px dx, e raised to power tan x dx. Integration of tan is secant, so this is, so integration of tan is log secant, no? Log of secant x. So what we can write here, log of secant x. So it's simply secant x here. So the integrating factor is secant x. Integrating factor हमारा कैलकुलेट हो चुका है. अभी नेक्स्ट स्टेप क्या होता है हमारा, to write down the solution. Now the solution is given by dependent variable into integrating factor na. Now see, what is dependent variable here, not y, it's z. Be careful at this step. We are solving a equation which is linear in z, not in y na. So the solution is z into integrating factor, integration of q of x into integrating factor with respect to x plus constant of integration c. Integrating factor has value secant x. Let's put there. The value of q was, the value of q, cos square x into secant x dx plus c. This is z into secant x. Now this is cos square into secant. If you see, secant is 1 by cos, 1 cos is getting cancelled out now. So it is simply cos of x dx plus c, which is z into secant x is equals to integration of cos is sin x plus c. बैक सब्सिट्यूट द वैल्यू ऑफ z. z हमें किसे पुट किया था हमने z को, we substituted secant y is z, right? So this is secant y into secant x is equals to sin x plus c, which is your required solution. Clear? Now let's have a look at one more example. Example number 2, which is x dy by dx plus y x cube y raised to power 6. Now see, this equation is also reducible to Leibniz form. Although this is of order 1, you see, and degree is also 1. But this is non-linear in y as well as non-linear in x. देखो y में तो पहले ये linear बन ही नहीं सकती because of ये y raised to power 6 present है ना. अगर आप इसको convert करना चाहो कि चलो dx by dy form में बना लेते हैं ना, the alternative form dx upon dy, still you are not able to because of the presence of x cube. So what we can do here, again we can do, try that can we convert it into Leibniz form like just we did in the last example. If you remember what we did, first we make our right hand side free from y. So I will divide it by y raised to power 6 when you're going to do this. Also, if you remember one thing, we always want that the coefficient of dy by dx should be 1 ना, यहाँ पे भी 1 होना चाहिए. So I will divide it by x as well. So I'm going to do that in single step. Divide by x y raised to power 6. So what I will get here, y raised to power minus 6 dy by dx, y raised to power minus 5 1 by x, because we are dividing it by x na, by x equals to x square. तो x into y raised to power 6 के साथ डिवाइड करने पर हमें ये फॉर्म मिल जाएगी. We get here. Now what I told you in the last example, once you are done with the dividing, जब आप एक बार डिवाइड कर चुके हो, डिवीजन के साथ आपका एक बार रोल प्ले हो गया है. Now what you have to do is just substitute y raised to power minus 5 as some another variable. अभी इसे हम पुट कर देंगे y raised to power minus 5 को z, put y raised to power minus 5 at z, do the differentiation, minus 5 y raised to power minus 6 dy by dx is equals to dz by dx. Like I told you earlier as well, every time you are going to have the same expression, the only difference can be of a constant number. mere constant का difference हो सकता है, but the जो expression है y में वो same बनेगा. So substituting the value in equation number 2, what you get here, minus 1 by 5 dz by dx plus 1 by x time of z is equals to x square. Shift minus 1 by 5 to other side, so this is minus 5 upon xz is equals to minus 5 x square. Now doesn't this equation looks like Leibniz form? Now this is Leibniz form if you compare it with dz by dx plus p of x z is equals to q of x, where the value of p is minus 5 by x and the value of q is minus 5x square. Now we will solve this in our usual way. Now the integrating factor is given by e raised to power p of x dx, e raised to power minus 5 upon x dx, e raised to power minus 5 log x. Again using the formulation for log, shifting the minus 5 to the power of x. The indicating factor is x raised to power minus 5, and the solution is given by dependent variable z into indicating factor equals to right hand side into indicating factor dx plus c, which is z into x raised to power minus 5. The right hand side was minus 5x square into x raised to power minus 5 dx plus c. Put the value of z. Z किसे put करा था हमने? We substituted z to y raised to power minus 5. So y raised to power minus 5, x raised to power minus 5 equals to minus 5 outside, integration of x raised to power minus 3 dx plus c. So this is 1 by xy raised to power 5 is equals to minus 5, integration is x raised to power minus 2 upon minus 2 plus c, 1 by x5, then it is 5 upon 2 x raised to power minus 2 plus c, which is the required solution, right? Now there is one more important thing which we need to discuss is Bernoulli's equation. Any differential equation of first order and first degree of the form dy by dx plus p of x into y is equals to q of x y raised to power n is known as Bernoulli's equation. इसे बच्चा Bernoulli's equation बोलते हैं इस टाइप को. ये जनरल फॉर्म है उसकी. दिस इज द जनरल फॉर्म. फर्स्ट ऑर्डर फर्स्ट डिग्री, बट इट्स नॉट लीनियर. अदरवाइज अगर लीनियर होगी फिर तो लिबनिस फॉर्म है ही. ये बर्नौली है जो नॉन लीनियर है. dy by dx प्लस p of x y is equals to q of x y raised to power n. डिफरेंस क्या है लिबनिस के कंपैरिजन में कि वहाँ पे हमारे पास ये टर्म नहीं होती है ना, y raised to power n. जो भी इक्वेशन इस टाइप की होगी उसे हम क्या बोलते हैं? बर्नौलीज इक्वेशन बोलते हैं. एंड what is the specialty about them? that every Bernoulli's equation can be reduced to Leibniz form. अभी जो हमने एग्जांपल सॉल्व करी ना just right now, this was a example of Bernoulli's equation. Just see, dy by, if I divide this by x na, if I modify this by dividing it by x making coefficient unity, this will something look like this, right? Now see, dy by dx p of x into y q of x along with that y raised to power n with the value of n to be 6. तो ये जो इक्वेशन है ये स्पेसिफिक कैटेगरी की इक्वेशन है. इसको हमने क्या नेम दे रखा है? वी हैव नेम्ड इट एज अ Bernoulli's equation. Also it can be in alternative form as well, that is in the terms of x like this. If I consider x as dependent na, dx upon dy plus p of y x is equals to q of y. ये कौन सी फॉर्म है? Leibniz. अब इसके साथ हमने क्या इंट्रोड्यूस कर देना है? x raised to power n. Now this has become Bernoulli's equation. अब ये Bernoulli's equation बन गई है. और इसको सॉल्व कैसे करना है हमने? बाय रिड्यूसिंग इट टू Leibniz फॉर्म. Leibniz फॉर्म में कैसे कन्वर्ट करेंगे? बाय डिवाइडिंग द होल इक्वेशन विद द फैक्टर x रेज टू पावर n. उसके साथ डिवाइड करके हम इसे क्या करेंगे? सॉल्व कर सकते हैं. ओके, now you can give these examples a try and let me know if you have any doubt. We can cover them in our next video. Thank you.